So let's go ahead and talk about Antarctica and how it affects everything, because it's part of the feedback system. Antarctica has an annual ice sheet, and this is how the ice sheet extent, or actually I guess I should say sea ice extent. And here's how the sea ice extent looked on August 25th. It's kind of an annual event. It doesn't really change that much, year over year. But Antarctica is also melting, as you can see, and it's causing a very cold sea surface anomaly around it. And you can tell the parts of Antarctica that are melting the most by looking at the sea surface anomaly and see where it's splashing out with those impressionistic blues. Let me show you. So we know that we've got a lot of melting going on. This is West Antarctica. We know we have a lot of melting going on here and in here, but look at, it's reflected in the sea surface anomaly, and that is actually real data that's being painted by the sea surface anomaly. So this is the impressionistic painting that Antarctica is actually making as it melts. This is all Antarctic ice melt. And over here as well, over on the east side, we can see this melting here mirrored over here. This map from April 2015. Here's a map of Antarctica if you need one for reference, and it has a lot of different bits on it. So the part that is melting down right now is West Antarctica. East Antarctica is melting as well, but not as strongly. But we do know that the West Antarctic ice sheet has been irreversibly destabilized, which means it's going to melt entirely. It's a matter of time. So we're in a slow motion process from this destabilization of West Antarctica, and we will find that ultimately West Antarctica is going to result in 3 meters of sea level rise. West Antarctica is really hot, and you can see in this positive temperature anomaly map, well, it covers a little bit into East Antarctica as well, truth be told, but here's West Antarctica right here, and here's East Antarctica. So you can see that there's a lot of hotness right here. It's not normal. Over the last 50 years, Antarctica has heated up a lot, and we can see here the red regions really represent the places where the temperature increases has been the highest in the last 50 years, and that's West Antarctica. And it is melting. There's no way around it. The massive collapse of ice sheets in West Antarctica has now begun. Eric Rigneau, a polar scientist, and by way of JPL, Jet Propulsion Laboratories, and University of California, Irvine, please check his videos out on YouTube. He's very good. He has made this map that basically plots all the velocity of the ice sheet. So this is another ice sheet velocity map, and you can see which parts of Antarctica are melting the fastest, the blue being the fastest and the brown being not. This is a crack that opened up in 2011 in the Pine Island Glacier in Antarctica. And this particular crack, this is a picture from 2011, and scientists working there discovered a massive crack in the Pine Island Glacier, and it really was pretty sizable. It was 30 kilometers long, 80 meters wide, and 60 meters deep. So that is absolutely huge. Now, the reason we bring this up is ice shelves tend to crack when the ocean goes up and down, when it gets jostled, when heat sets in, when it gets weak, and it's an ongoing process that we're going to be seeing really escalate in West Antarctica. It's important to understand that these ice shelves are primarily melted from the warm ocean that's below, and that they actually work, the ocean actually works its way in, hot ocean by the way, works its way in under the ice shelf, under the ice sheet, and into the land itself. And if there are dips and valleys, well, you can be sure as soon as it gets past, the ocean water will soon populate this, and that'll just accelerate the ice sheet demise in West Antarctica and really speed everything up even more. Another thing that's been happening in Antarctica is the winds have been picking up around the continent itself, and these giant vortex of winds around Antarctica has been exacerbated and spun up by greenhouse gas emissions. It's pretty stunning when you see it this way. So let's take a look and compare the sea ice extent. So we're not talking anymore about ice sheets, but we're only talking about sea ice extent between the Arctic and between Antarctica. And what we see here, look at Antarctica in blue. Antarctica is pretty steady year over year over year. I mean, people say it's increasing a little bit, but it's not really notable. It's just sea ice extent, and it's an annual event. However, not so true in the Arctic, right? I mean, look at this map, graph going back to 1985, or 1980, sorry, 1980. We can see it's just dropping down, and that we will at some point be at zero because it's not going to recover in the Arctic. Antarctica is losing a lot of ice, and it's exponentiating as well, but it's losing in the realm of hundreds of gigatons of ice a year. And we find that Antarctica's ice melt is actually exponential as well. So if we look at the mass variation of the Antarctic continent itself, we can see that the mass is going down, and that is because Antarctica as a land mass is becoming lighter as the ice runs off. And this is a pattern that, of course, is exponentiating and will continue to do so.